So this would be the first video of a couple of videos where we're going to apply the derivative rules that we know. So we know the chain rule and the general power rule within that. We know the product rule as well as the quotient rule, and of course addition and subtraction, which we have learned is fairly easy and we really don't need to break those apart anymore. So in this, we're asked to just simply take the derivative of the following function. So we have 2x minus 3 as a term multiplied by x squared minus 3 cubed. So we are looking at a few different rules, and you might notice right away that the first is the product rule will need to be applied. And then from the product rule, you can see that we will be using the general power rule and the chain rule. So all three of those will need to be applied. So let's set this up using that product rule, and we'll say for the derivative y with respect to x. And the way that I'm going to set this up is I'm going to begin with, of course, the derivative d with respect to x of the first term, which is 2x minus 3, multiplied by x squared minus 3 cubed plus the derivative d with respect to x of the second term, x squared minus 3 cubed multiplied by the first term of 2x minus 3. I'm going to rewrite that. It looks a little bit like a 4. That's not good. So you may see that I do this a little bit differently, and it's okay because the multiplication is commutative, that we could move these around if you're more comfortable doing that. That's just fine. Just remember that however you do it, make it consistent. Make sure that you're using a process that you can repeat each and every time. So let's go ahead and begin reducing what we can quickly. And 2x minus 3, the derivative of that is simply going to be 2. This whole thing becomes 2 multiplied by, and we just bring this down. That doesn't change. It's not a derivative of. We just simply bring this down. Minus 3 cubed plus, and then we can bring 2x minus 3 down plus 2x minus 3 multiplied by, and here's where we need to use our general power rule and chain rule. So we're going to say that, and I'm going to show the steps all the way through. I know that we're probably being shown right now how to take that first step right away, which would give us, if I show this, which would give us 3x squared minus 3 minus 1. That's going to give us 2, and then we would be taking the derivative from there. I'm just going to show you for now that we are multiplying by the derivative y with respect to u, and we are saying that that y, let me just write this out. We are saying that y equals, and we are calling that u to the third, and we are saying that u is equal to x squared minus 3, just to show you what we're doing within an application. So I'm going to say the derivative y with respect to u is u to the third multiplied by the derivative with respect to x. That's going to be this inside portion. That's the inside portion. So we're going to have x squared minus 3 And now I'm going to go ahead and distribute a few other things. So let's see here. Sorry, I thought I could distribute that. Never mind. I'm going to go ahead and just bring everything down. All right, so we're going to take the derivative here, and that's simply bringing down your exponent. And I'm going to leave this as 3, and I'm going to leave this as 3 to the u, 3 to the u squared, because that exponent is 3 minus 1. I'm going to multiply that by the derivative of x squared. Well, that's going to be 2x. And now I'm going to substitute. So for this u right here, I'm going to substitute that term back in. So we end up with 2x squared minus 3 to the third plus 2x minus 3 multiplied by 3, and I'm going to substitute the u. So I'm bringing x squared minus 3 back in, squared multiplied by 2x. And as you do these more and more and more, you'll see that pattern. You'll be more comfortable with it, and you can skip. You can basically end up skipping this step and going right to this. So I'm hoping that you see this is really what we can get to immediately right here. We would have 3 times x squared minus 3, all of that squared. So hopefully you begin to see that, but I am hoping that this also helps you effectively look at what's going on and where each one of these terms and derivatives are going. So now that we have this taken care of, now we can finally combine like terms. And we can say that this is 2x squared minus 3 to the third plus, and let's go ahead and take care of the 3 and the 2x. So we have the 3 and the 2x can be combined. That's going to give us 6x multiplied by 2x minus 3. That multiplied by x squared minus 3 squared. And in looking at this, we can see that we have an x squared minus 3 and x squared minus 3. And the most we can take out, we can factor out of this, is going to be x squared minus 3 squared. So we'll be able to take 2 out of there. So let's do that. So we end up with x squared minus 3 remember the exponent, multiplied by, and I'm going to go ahead at this point, because this is taken care of. We have reduced on this side the x squared minus 3. We've reduced this to just the first power, so it's just 1, which means that I can go ahead and bring my 2 through, and I can also bring my 6x through. So let's do that. So 2 times x squared, that gives me 2x squared, minus 3 times 2 is 6, plus, and I no longer need the parentheses because I've carried this 2 through. There's no longer a product here. So I can leave that without parentheses now. And the same thing here. I can bring my 6x through to 2x. That gives me 6 times 2 is 12. X times x is x squared. 6x times negative 3, so that's minus 18x. And the last thing we can do is we can combine these like terms. We have a positive 2x squared and a positive 12x squared. So we can finalize this in simplified form as x squared minus 3 squared multiplied by 14x squared and from greatest exponent to least, I would write this as 14x squared minus 18x minus 6, and we're done. Hope that helps. Thanks for watching.